So welcome to Evolving a Legacy System with Architecture for Flow. So in some heads up, I tend to cover a lot of content, but I will provide a link to my slide deck at the end of the presentation. And I also just recently, finally published a book about this topic. So if you're interested in this topic, you can explore it with the book as well. So who of you has to deal with legacy systems on a regular basis? So yeah, I see a lot of hands. And who of you, in the words of Marie Kondo, for who of you does your legacy system spark joy? I don't see hands. How come? Yeah, that's the pity about it, right? Usually when we talk about legacy systems, usually negative attributes come to our mind, right? But we also have to acknowledge the value of legacy systems as well. So legacy systems, they represent past success, right? They contain years of accumulated domain knowledge. So they are battle tested and they are stabilized over years. So they are standardized and stabilized over years of production use and are still standing. They are deeply integrated into the workflows and processes that our teams are relying on every day. So they are representing proven business value. On the other hand, usually legacy systems, they are perceived as innovation constraints as well. So they have evolved over the time, or many of them have evolved over time in large, intertwined, tightly coupled, big ball of mud systems with messy models and no clear modularity boundaries, and with a tightly coupled architecture that can also represent a constraint in our system. So because we are then dealing with unpredictable side effects, when we try to change one part of the system, can lead to unpredictable side effects that can cause defects and a lot of rework. And also, it is also over the time that can have accumulated technical debt, where lack of test coverage or complex code, high code complexities, and also leads to fragile code bases that are hard to maintain long term. And then also with messy models and no clear modularity boundaries, it's also pretty difficult to establish clear ownership boundaries, so that could lead to lack of clear ownership and a decrease of accountability and kind of like, oh, no, that is not my job syndrome. And also with this messy model or with this large intertwined system with messy models, no clear modularity boundaries, also then tends to be or leads to teams owning too large or too many parts of our system. And if teams own too many or too large parts of the system, their team cognitive load exceed. And if the team's cognitive load is largely exceeded, it also becomes a delivery bottleneck. And also, when the teams do not own the fully end-to-end flow from designing, developing, testing, releasing, and also operating the parts of the system they're responsible for, so then they have to repeatedly hand off some work to other teams. So they depend on other teams' activities and tasks that they do something to get their own work completed. But with repeated handoff, they represent blocking dependencies, and they require a lot of communication and coordination efforts, and also leading then to a lot of wait times and delays, and also considered as constraints in our system. And there are many more impediments as well. So, for example, when teams lack priority and focus, when they're switching back and forth between tasks without completing them, leading to high work in progress, or when with unplanned work from the technical debt, for example, when they have to switch back and forth to high context switches, and also becoming constraints of our system. So, when evolving legacy systems or when building systems in general, we face the challenges between building the right thing or building the thing right. And building the right thing addresses effectiveness, addresses questions such as how aligned are our solutions to our business and user needs? Are we generating value for our customers? Have we understood the problem, and do we share a common understanding of the problem domain? Building the thing right, on the other hand, that focuses on efficiency, for example, efficiency of our engineering practices. And it's not only crucial to generate value to our customers, but also being able to deliver that value to our customers. And how fast can we deliver changes, and how fast and easy can we change and adapt to new and changing circumstances? So the one does not go without the other, but Dr. Russell Eckhoff, one of the pioneers of the system thinking movement, stated that, I have to read it, otherwise I get it wrong, doing the wrong thing right is not nearly as good as doing the right thing wrong. So building a wrong product efficiently is still worse than building the right product inefficiently. Or as John Cutler says, crap delivered quickly is still crap. Unless we learn something from that crap and act on that learning. So to build the right thing right, we need to design, build, and evolve adaptive socio-technical systems that are optimized for a fast flow of sustainable value and constant feedback. And one approach out of many is by achieving this is by combining business strategy with Wardley Mapping, software design and architecture with domain-driven design, and team organization with Team Topologies. And it's very long to always repeat it, so as short, architecture for flow as a holistic tool set. So let's start with building the right thing. So let's start off on the effectiveness. So to build the right thing requires to start from the user perspective. And Clayton Christensen, the inventor of the Jobs to be Done theory, stated that people buy products and services in order to get a job done. In order to help users to get their job done, we need to know who our users are and what are the jobs they want to accomplish, and what are the desired outcomes as user needs that they want to achieve when getting a job done. And as an example of an online school solution, one of the users are the teachers, and their core functional job is to facilitate remote learning. In order to accomplish this job, they want to prepare learning material, they want to assess the student understanding with assignments, they want to track the students' progress over time, and they would like to facilitate communication with the students and also ensure a secure access to the learning platform, for example, with sign-up and sign-in processes. And the jobs to be done, the user needs, they are describing the problem space, and they remain the same regardless of how we are going to solve them in the solution space. So they don't care if we use the shiniest AI, as long as we are fulfilling the user needs effectively and efficiently. So in the solution space now, those user needs are directly or indirectly fulfilled by a chain of components, and that's to generate value to the users by satisfying those user needs. And that's why we can blend in the value chain, that is the y-axis of a Wardley map, where the users and the user needs are representing then the anchor of the map. And the value chain itself, it shows how different components connect to generate value by satisfying those user needs. And it's visualized like how the dependencies. So in this example of the online school solution, the teachers are interacting with an online school component. We come to that one later on. And this online school component depends on infrastructure components, which are less visible than the online school components. And we can start small and can iterate later on. And then the components of those value chain are going to be mapped to evolution stages, with genesis with brand new things, then custom build, then product and rental such as off-the-shelf products or open source software solution, and commodity and utility at the right. And creating a Wardley map within a group that helps to create a common understanding of our business landscape and organizations operating and competing in. And it helps also to challenge our own assumptions. And it also helps to assess efficiency gaps. For example, are we custom building commodities, or are we custom building components that not belong to our core domain? Or can we utilize further evolved components as well? So the map helps to identify where to invest and innovate, and what to evolve in order to gain competitive advantage. And I personally use the Wardley map a lot during modernization processes as well. So switching now from the effectiveness to build the right thing, now switching to the building the thing right to the efficiency part, and to build the thing right, we need to optimize our flow of change. And we can use a Wardley map as a starting point, a high-level entry point, to assess how a change would flow through our system by tracing the dependency in our Wardley map, and to determine how a change would propagate through our system and what components would be affected by a change, but also to identify or to analyze what corresponding teams need to communicate and coordinate in order to make that change effective. Regarding to the teams, when we assess the flow, like still working on the efficiency part, is in an ideal case, the teams shall fully own the entire end-to-end flow from first idea to delivering value to our customers with minimal bottlenecks, with minimal impediments along the flow. And teams often know what is slowing down their daily flow of work, and meeting teams where they are and interviewing them about what are your current blockers to flow, so what are the impediments we need to minimize, can be the starting point for optimizing a system for flow. But not only the blocking elements, but also what are the elements that working well in our flow. So what are the points or the elements that we would like to keep in our ideal future? And those pain points later on we can use to revisit later in order to identify what of those blockers we have addressed, what of those blockers to flow still need attention, or maybe new blockers appeared. And to analyze blockers to flow can be done, that is just an example, from various perspectives. So for example, from the team ownership perspective, do they own too much or too large parts of the system? Is the cognitive load largely exceeded? Do we have team dependencies with blocking dependencies? Also from software architecture quality and software architecture and software quality perspective, and also from the work management perspective. So are we dealing with tightly coupled architecture, with high technical depth involved, also like work of management, like lack of clear priorities and focus and so on. So it's something that we can analyze from the beginning and asking our teams about it. So to optimize now our flow of change, usually can start from identifying the streams of changes. So, and for that we need to identify, to analyze what will drive value and change in our organization, and identify where the most important changes in our system occur, the streams of changes. And the user needs of our Wardley map, they are representing good candidates for customer-driven streams of changes. So we need to structure our teams and our system around these streams of changes in order to optimize our system for a fast flow of change. And the users and the user needs are not only representing streams of changes or the anchor of our Wardley map, but they also represent the problem domain, and that's where domain-driven design comes in. And domain-driven design helps to gain a shared understanding of our business domain. So, and it helps also to partition our problem domain into smaller parts, into subdomains. But not all subdomains are equal to the business in terms of differentiation. So we have different types of subdomains. So the core domain, that is the essential part of our problem domain, providing competitive advantage. That's the part of our system that we want to strategically invest in most. So that's usually the parts that we want to build in-house. Then the supporting subdomains, those help to support the core domain, so they are complementing the core domain offerings. And they do not provide competitive advantage, but they are necessary for the organization to succeed. So they are, so supporting subdomains are specialized but non-differentiating. and the generic subdomains that are subdomains that many business systems have, for example, authentication and registration. So they exist in every business system, while supporting subdomains solutions, they usually also exist in competitive solutions. So, and the generic subdomains that are neither specialized nor differentiating. So, and by categorizing the problem space into the core, supporting, and generic subdomains, we get an idea where the organization can, or get an indication where we can, in the solution space, then prioritize our strategic investments and get an idea where the subdomain solutions, what to build, buy, or outsource in order to gain competitive advantage. So, and when we now switch to the solution space, in the current online school example, in the solution space, the subdomain are all mingled together in one monolithic big ball of mud, which is causing then tight change coupling with messy models and fuzzy boundaries, lack of clear ownership, high team cognitive load, and also custom building parts that are not belonging to our core domain. So, and then also affecting our flow and efficiency as well. So in order to move away from it, one thing is to architect for change and leverage the power of small. And that means that we have to move away from our monolithic big ball of mud with messy models and fuzzy boundaries, and leverage modularity with functional cohesion and loose coupling by designing modular, well-encapsulated, loosely coupled systems, and which requires to decompose our monolithic big ball of mud into modular components. And that brings us again back to domain-driven design. That brings us to bounded contexts of domain-driven design. A bounded context itself groups related business behavior together, and that are boundaries representing boundaries where a domain model is applied. That represents encapsulate particular business logic in our subdomains. And bounded contexts are enforcing high cohesion and modularity from a business behavior point of view, but they also represent good, well-defined ownership boundaries. We come to that one in a second. Designing bounded context and domain models, integrated domain models, that usually involves a close collaboration between domain experts and development teams in order to gain a shared understanding of our problem domain. And there exist different techniques, modeling techniques, collaborative modeling techniques to design this bounded context and domain models. One of them is event storming. That is a lightweight modeling technique based on color-coded sticky notes that was invented by Alberto Brandolini. And event storming allows us to explore complex business domains by mapping out domain events that are things that has happened in our domain and along a chronological timeline. So, and we usually can start this conversation coming from the Wardley map from the user need perspective, and we would like to, for example, what is happening in our domain when a teacher wants to prepare learning material, or when a teacher wants to assess the student understanding with assignments. And all these insights that we are then gaining through these event storming sessions are then expressed in domain events, for example, course outlined, or content published, or exercise assigned, or student enrolled to class. So that are then technology agnostic, domain specific events that has happened in our domain. And event storming helps us to share domain knowledge on the one side, but also helps us to identify the so-called bounded context that groups related behavior together. And for example, content creation, assessment, and so on. And those identified bounded contexts can then be brought back onto our Wardley map as part of our value chain. And so in order to connect it to our future landscape where we want to move to. And together with the subdomain categories of core, supporting, and generic, we can now better target our strategic investment in the solution space. So for for example, the major development effort, we have to focus on our core domain-related bounded context. So that's the one that we focus on building in-house. And for the generic subdomain-related bounded context here of identity and access, there we can evaluate whether we can use existing solutions, because the bounded context, this generic subdomain-related bounded context do not provide competitive advantage, neither is it specialized. So it usually entail very common standardized processes and functionality where we can also then leverage existing solutions. And for the supporting subdomain-related bounded context, the decision whether to build or buy is a little bit more nuanced. So they are non-differentiating, but they are specialized for our domain, and they support the core domain offering. So, and we need to figure out whether they are so specialized that they require custom-built development, or if they are, we can also leverage existing solutions in the market. Whether we could leverage further evolved components is not restricted to our bounded context, but also to the entire value chain. So we can also ask questions, in our example, for example, can we evolve our on-premise infrastructure components and increase the efficiency and migrate them to cloud-hosted services that are available as a commodity in order to close previously identified efficiency gaps. So, and now, so that is what we are envisioning in our future landscape. And that the next question is like how to align our teams. And from a team perspective, we need to find suitable team boundaries that are aligned to the customer-facing streams of changes. And as stated previously, the bounded contexts provide well-defined ownership boundaries. And that makes the bounded context not only good candidates for splitting our system into modular, business-specific modular bounded context components, but also good candidates for team ownership boundaries for streamlined teams. And that brings us to team topologies with their well-defined team types of streamlined teams that focus, that are cross-functional autonomous teams that are aligned to a continuous stream of work, focusing on fast flow of change. And they get support from the other teams, for example, from the platform teams that support the streamlined teams delivering their value by providing self-service capabilities that the streamlined teams can easily consume. Or they can get support from the enabling team by working as internal coaches to upskill streamlined teams or other teams on demand to that they can acquire missing capabilities, or complicated subsystem teams. That is a very optional team type. They are very specialized teams of very specialized knowledge. For example, machine learning or like mathematical models or low latency systems, ultra low latency systems, something like that. So it's really specialized knowledge that's not worth spreading across every team. So as an optional team type. And to arrange these teams and these team types is not enough how to become effective from an organizational perspective. How they are interacting and when to evolve this interaction between teams is also very crucial for organizational effectiveness. So with collaboration, the teams are working very closely together over a short period of time. So it's meant to short-lived. So it's usually applicable for rapid discovery of teams. Then X is a service that is something when a team provides self-service capabilities to other teams so that the consumer becomes self-sufficient to consume the platform underneath, for example, for platform teams. And facilitating, that is the interaction mode that is typical for enabling teams for coaching, for example, or upskilling other teams. So coming back to our Wardley map, to maintain the fast flow of the streamlined teams, they need the support from other teams as well, and to support them delivering their work, such as, for example, from platform teams. And to provide provide platform capabilities requires then identifying services that support a reliable flow of change and can be delivered as platforms that providing self-service capabilities and can be autonomously consumed by the platform consumers. And the platform can abstract away on different levels, for example, On a low level, it can abstract away infrastructure and cross-cutting capabilities. On a higher level, it can also be a data platform. It could be a design system as well. So it does not necessarily only infrastructure components. So depending also on the organizational context. And also, as said earlier, simply organizing teams and the team types is not enough to become effective. How the interaction can evolve over time is also very crucial. So for example, a platform team may initially collaborate with a streamline team for a limited period of time in order to understand the streamline pain points and what their user needs. And they might revisit the previously collected pain points in the beginning. And over time, this collaboration could evolve into X as a service, where then the platform teams provide self-service capabilities that the streamline teams can autonomously consume. And additionally, also other streamline team can share some knowledge as well, or for rapid discovery, collaborate together, and maybe enabling team can emerge in order to upskill other teams. So, and how to bring those concepts together. So I developed a structured approach as an architecture for flow canvas. So that is an opinionated structured approach, but that's what I have, what I'm applying with my client engagements, and also adjusted to the organization context. So you can, it's not a rigid framework, just to say it. It's not complete. It gives you as little structure as possible, and you can complement it with other techniques as well. You might want to start with another step, with a different step, or you might skip a step. That is really then depending on the context. And however, it is an iterative, continuous approach, and we do not want to end up with a big upfront one-off design. But we want to get as little design as possible that gives us enough direction to move forward step by step. And it typically begins with the teams of today and then ends with the teams, or envisions then the teams of tomorrow. So it starts with assessing the current state and from the team, current team organization. What are the teams? What are the responsibilities? What are the dependencies between teams? And also assessing the current flow of change, identifying the blockers of flow, interviewing them, what blocks your daily flow of work. Also mapping the current business landscape in which the organization is operating and competing. And then also, so to get a first understanding of our current as is, our status quo. And then transitioning to our ideal future. As said, it's not a big upfront design, it just gives us direction how to move forward. And starting then categorizing with a problem space, where do we see core supporting generic subdomains, and switching to the solution space in terms of how to identify modular components, for example, using bounded context with event storming sessions, and bringing them back on a Wardley map to envision then our future landscape that we want to compete in the future and operate in the future, and then also addressing then the team ownership boundaries and where do we see streamlined teams' responsibilities, platform responsibilities, and then also identifying capability gaps for enabling teams later on. But this is like, okay, we have now designed as is and to be, but that is more the theories that where we are right now and where we want to go in the future. But the question is, how do we get there? So it's, and we don't want to have a big bang, one-off transformation. We need to follow, because it's really expensive and risky, so we need to follow an incremental evolution. So when it starts, to give, yes, for example, in the example of the online school, the incremental evolution is characterized by reteaming the existing teams, which involves moving functional silo teams that they are currently addressing into, for example, Team Topologies team types. It involves replatforming the on-premise infrastructure to migrating them or moving them to cloud-hosted services. It involves then refactoring the big ball of mud into modular components, such as bounded context. and evolving then the team interactions along the journey. So it is so in this example, it is characterized by these elements, but maybe a different organization has to apply different techniques as well. So that is not a blueprint for every legacy modernization. So the transition starts from the status quo, where the teams are currently organized as functional silo teams with front-end, back-end infrastructure operation teams that own a monolithic, tightly coupled big ball of mud system, which is operating on an on-premise infrastructure. And the team's flow of change is currently interrupted by blocking handovers. So that is our current status quo. And now we want to move away from it without a big bang transformation. So the transitions could start with small teams, can start with small steps. So it could start with forming, in this case, with forming, for example, a platform team, first from the members of the previous functional silo teams. And this new platform team can then start the replatforming cloud migration journey. And with replatforming, we are replacing the on-premise infrastructure component with cloud-hosted services while we keep the architecture the same. So the architecture still remains the same. And from there, we can then start the modularization. I have always problems pronouncing this word. So there we can start the modularization of the monolithic monolithic backend, where we first formed then the streamline teams, and they are now kicking off the refactoring journey. And the refactoring journey now focuses on decomposing the monolithic big ball of mud into modular components, the previously designed bounded context, step by step. So, and to address then the applicable cloud option, because now we are running on a cloud infrastructure, to address the applicable cloud option for the new bounded context that the Streamline team is going to be responsible for, it can be supported by an evolution of interaction modes. So it can collaborate with the platform teams to discover what applicable cloud options are beneficial for our bounded context. And this collaboration can then later evolve into X as a service. And the next Streamline teams can form, and they are carving out now their bounded context and from the monolithic big ball of mud. And during their refactoring journey, they are also supported by an evolution of team interaction modes, where, for example, where the previous Streamline team can share their internal knowledge when they are refactored their bounded context. They can share refactoring knowledge, or the platform team can also share some knowledge about the cloud infrastructure, or get supported by X as a service, self-service capabilities as well. And then the next Streamline teams can form. So it is transitioning team by team, and they can also continue their refactoring journey. And they are also supported by evolution of team interaction modes along their refactoring journey. So, and all these insights during our incremental evolution, all the insights and experiences we are gaining, that can also course correct our initial assumption of our ideal future. So we are constantly getting feedback for our ideal future as well, and course correcting accordingly. So to summarize, optimizing a legacy system for flow starts with assessing our current status quo and designing our ideal future. That's where we can use an architecture for flow canvas that helps seamlessly combines Wardley Mapping, domain-driven design, and team topologies, assessing our current as-is situation from the team perspective, our business landscape, blockers to flow, and so on, and also designing our ideal future, like what kind of bounded context we want to achieve, what are our ownership boundaries for teams, aligning the teams, and also evolving their interaction. And so in designing the future state as a first working assumption that provides an initial direction for movement. And there we can then transition in from the legacy system into our ideal future through an incremental evolution based on our as-is situation and a designed ideal situation. And in this example, we were using reteaming, replatforming, then refactoring, and into evolution of team interaction modes. And each incremental change that we gained, that we performed, we get new insights in our system, our current system. And we can course correct like our current understanding of our current system, but also course correcting our ideal future. So it's not a one-off initiative. It's continuously evolving. So it is a feedback loop involved. So. And at this stage, the initially identified blockers to flow can be revisited to assess what blockers to flow we could then transform into supports for flow. And maybe we have not addressed every blocker to flow. Maybe new blockers have emerged, so there is also then the possibility to revisit the identified blockers to flow that we have previously identified. And so this architecture for flow approach helps us to unlock a variety of blockers to flow in order, and from a architecture, team ownership, team dependency, and also efficiency gap perspective. So the combination of Wardley Mapping, domain-driven design, and team topologies that helps us to generate sustainable value aligned to user needs. It helps us to unlock our blockers to flow. It helps us to architect for change and leverage modularity, leverage the power of small. It helps us to focus our major development investments on our differentiators, providing competitive advantage. It helps us to close potential efficiency gaps and align our teams and evolve their team interaction to the system we build and the strategy we plan. So this combination provides, in my humble opinion, a powerful tool set to design, build, and evolve adaptive socio-technical systems that are optimized for a fast flow of sustainable value and constant feedback to build the right thing right at the end. And to close with Marie Kondo's words, we shall thank our legacy system for the service and evolve it with gratitude. And with that, I have also provided some resources. As I said, if you're interested, I published a book about it recently. It's also part of the charity auction as well. And with that, I thank you so much.
So I'm easily over my depth here. Just that's a caveat. How much of this approach is related to Michael Feather's work on seams? So I'm not sure I understand that wholly either, but I understand the bounded contexts and the domain-driven design concepts and the sort of slow refactoring. Is there a relation, for the complete layperson, is there a relationship with some of the other work on how to carve the stuff out?
Can you explain themes? What you mentioned,
So it's something I've only skimmed through. Okay. It's a book by Michael Feathers. It's about...
refactoring, yeah.
It
is, exactly, sorry, I could not get the name. Yeah, absolutely. It's the themes that Michael Feathers was mentioning. Its bounded contexts are the themes around it. So they are addressing the themes that they group related business behavior together, and where you can then start to carve it out, and you start small. Usually, also addressed it in the book, where you can go step by step. You don't have to. It's minimal invasive, where you, for example, go from technical layer to business-centric modules, and it's a refactoring on module, on model and data level and communication level, and you can go step by step and finding themes where to carve out then this bounded context.
Okay, thanks. That just helps me make sense of it.
Okay, great. Thank you.